Yeah, we are good to go.
Hey guys, I'm Ganesh from Covalent, and I'm joined today with my colleague Harish. And let me give a quick intro to myself, and then I'll pass the floor to Harish, and then we'll talk about what we're excited about the Web3 space and the role that Covalent plays in this stack. So I'm a physicist and a data scientist by training. I worked in the pharmaceutical industry for about half my career before pivoting to the big data space. So one of the challenges with the pharma industry is that it takes about 5 years to build an MVP. And in a year and a half, a lot of my friends were actually starting companies and raising money and then having an exit. This was happening in less than 2 years while I was still building an MVP. So I said, I want to get in on the action. So I pivoted my career to basically the cloud, the rise of the cloud. So in the big data space, basically every single big database that you can imagine, everything from Cassandra to big Elasticsearch clusters is something where I cut my teeth with. And about 3.5 years ago, so 2017, late 2017, we found this opportunity where for blockchains to gather mainstream adoption, it needs to talk to existing deployments of enterprise infrastructure. So if you look at how an enterprise rolls out technology, they always look for connecting middleware that extends their capability rather than outright replacing legacy technology. So this includes the people and the tooling. So the people, they're not really going to retrain their staff. It doesn't make sense to retrain your staff. It's very expensive to retrain staff. Also, the tooling. Why fix something that's not broken? So you're always going to find some COBOL server in the backend that has just been humming along for the last 35, 40 years. And it just you just have more and more and more systems being built atop this very fragile ecosystem. But that is the state of the world, and that's the world that we live in. So for this world, for blockchains to interact with more enterprise deployments, it needs to speak something like SQL. And SQL is the language of choice that almost pretty much every single database speaks, whether it's from Oracle or SAP or Microsoft or Google. SQL is the standard. SQL has been around for the last 40 years. And I guarantee you, because of Lindy effect, it's going to be around for the next 40 years. So what we decided is let's put SQL on the blockchain. And that way, you're able to understand, you're able to have full transparency of what's happening on the ledger, and you're able to make it connect to existing deployments like your Microsoft Excel and your Tableau. So your reporting and compliance people, it's seamless to adopt these blockchain technologies. So that was the genesis idea that we had back in 2017. Then, the two of us, Levi and myself, we're the co-founders. Levi has a very strong background in databases. He built CouchDB at IBM and other large distributed systems. Just two database hackers going out there and say, hey, let's do something. We really didn't know, didn't do a lot of our due diligence when it comes to like market research, market timing, total addressable markets, all those things that matter when you're starting a business. We did none of that stuff. And then the bear market hit. And so we were just like building and building and building. So built through 2018, built through 2019. And then sometime late 2019, we started seeing early signs of adoption. So I went out and started to acquire customers, and then we started closing some really good dApps. Well, let me continue on that story, but let me give Harish a chance to introduce himself and what he's excited about Covalent, and then I can continue with my story.
Ganesh always has the best stories, so we love listening to him. So hey everyone, my name is Harish. I've actually only been with Covalent. It feels like a couple of years, but it's been I think only like 5 months now. And I joined as part of the focus on the bottoms-up adoption with the developer ecosystem. So I look after developer relations And currently, the focus for us has really been engaging our developer community through active campaigns, just like the ones that I think some of you took part with Etherpunk. We've run a similar 1 million wallets with Gitcoin back in December. And we've also got a data science focused campaign currently taking place with Aave. And we will be also participating in the NFT Hacks ETH Global event next weekend. So these are the types of engagement campaigns that we really enjoy running, because it really brings out the creativity of the developer ecosystem in terms of the types of projects, the quality of the developers, and their creativity in building out everything from wallet dashboards to dApps. We've seen some phenomenal types of applications being built powered by the Covalent API. Very quickly, in terms of my background story, I came from the clean tech space and joined another blockchain startup in 2018 with our focus on, again, trying to address the discrepancy between ordinary developers trying to interact with this complex new emerging tech, and empowering any developer, Web2 developer, to be able to work with things like smart contracts. So it's basically an API abstraction of smart contract read and writes, so that you could do it just by making web API calls and interact with those smart contracts. I think I'm most excited just seeing the growth of the company. We've gone from, as Ganesh was talking, it was just him and his co-founder for probably 80% of the time the company's been around. And now I think we're pushing 25 people. So seeing that crazy growth and also just sort of seeing the adoption with the very large customers using our API and leveraging that data for NFTs, DAOs, wallet dashboards, all sorts of really interesting use cases. So maybe that'll be a good segue back to Ganesh to talk about sort of some of that that build that's taking place using our API.
Sure. So yeah, super excited to have Harish on the team. So back to the story, 2019 comes around. By then, we had already spent 2 years building this technology. Build it and they will come. That's what the phrase is, but that's not true at all. You have to go and find customers. You actually have to sometimes jam the technology down their throats because they don't understand what this thing is. And so we started seeing more and more and more traction. And then by summer of 2020, what happened was all of our metrics, all of our KPIs, all of the business metrics started going through the roof. We became profitable. Lots of good things were happening. And then that's when we came to a realization that what Covalent is really the third breakout category when it comes to crypto. The first being exchanges. So Coinbase, which recently announced their IPO, Binance is in that bucket. These are like billion-dollar companies, revenue companies, not token valuation. The second breakout category would be the custodians like BitGo and Anchorage. That's also a critical infrastructure piece. And then the third breakout category would be something like Covalent. And in this bucket, you would have chain analysis, which recently raised $100 million. You would have the graph, which has a lot of success, and Covalent. So that's when we realized, okay, this two-person team trying to sling some code and hit it out of the park is cool. But let's be serious about this. Let's get outside capital and let's scale this into a global global corporation, a global footprint. Like, let's actually change crypto. And so that's when we realized that we need to go raise capital. So we went out and raised some of the best investors, 1KX, Mechanism Labs, and then Woodstock. So Woodstock is an investor from India. They're super India focused. So India is a key market for us. And then CoinGecko and Alameda and a bunch of other investors. So we raised that round last summer. And then since then, it's been go, 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 go. So what that means is we built the team, we built the product, we built our customer base. So from the team side, we've grown from 3 people to about 25 people in the last 6 months. So rapid growth there. On the customer base, we've grown from 5 customers to over 100. I don't even keep track of this anymore. So, some massive growth there. In terms of the blockchains we're indexing, we've grown from just Ethereum to 6 other blockchains. So massive growth on the supply or on the data side. So that's what's happened. And then now what's happening is I think we're geared up for this year. Global expansion. We're going to be expanding into India. We're going to expand into South Korea. We are doing lots of other ambitious things. So that's really what our journey has been. So going back to what exactly Covalent is and why this matters to the space. So what we've built is we've built a unified API to pull out balances and positions and transaction activity. And to truly understand Covalent, you really have to suspend belief and move 4 or 5 years from now. So let's say 2025. What our belief, our vision is that there's going to be a very vibrant ecosystem of blockchain-based protocols. So it's not clear if it's ETH 2.0. It's not clear if it's Near protocol. It's not clear if it's like Cosmos or Polkadot, but it doesn't really matter. These things are here to stay in some form or fashion. In that world, what you will need is regular developers will need to be able to interact with these systems, pull out the data, build compliance reports, do reporting, all kinds of analysis on this base layer data. And that is the world that we're building for. So it's agnostic for any blockchain protocol. It is horizontally scalable. So it cuts across different use cases in different verticals. But 2025 is still very futuristic. In the crypto world, things move very, very fast. So there's basically a shift every 6 months or so. So it's very difficult to pinpoint. So let's scale back. And in 2020, 2021, what are these 100 customers? What are they doing? What are they paying money for? Why is this so exciting? So right now, for Web2 developers to adopt Web3 technologies, there is a pretty heavy lift. What that means, they have to understand consensus algorithms, they have to understand blocks and transactions and transaction receipts, log events, ABIs, a lot of stuff. It's just a heavy lift. It's not like Web 2 where you write some code with a starter kit, maybe you use a React starter kit, create a React pack, and then deploy it into Heroku, and boom, you're ready to go. It's all up and running. Everything is plug and play. You go to the Heroku marketplace, you can plug in analytics, you can plug in logging, you can plug in monitoring, you can plug in communication using Twilio, you can plug in payments using Stripe. That's really not built out in the Web3 ecosystem. So by having a very simple REST API, and by having the same API and the same request and response shapes, we're able to pull out data from a lot of the underlying blockchains. So let's say you build something on Ethereum and you pull out, let's say, log events on a particular contract, and then you redeploy that contract onto another EVM compatible chain like Polygon or Binance Smart Chain or Avalanche. Now, what the developer really loves with Covalent is all they have to do is use the exact same API, but just change the chain ID. You change the chain ID, and then boom, you're now supported on the other blockchain. So what would have taken probably 1 or 2 weeks to support a new blockchain is now just a matter of maybe 5 to 10 minutes. That's it. So that's really how we focus heavily on time to market. And everything from the company perspective itself is just Web 2, right? We're bringing a Web 2 style experience to Web 3. That's really what we're bringing in. So on the product front, for example, it's crucial that the product is usable from the browser. So you go to the website, go to covalenthq.com, sign up for an API key, go to the API docs, and you should be able to use the product from the browser. That is a key product requirement that we've set out. And developers really love this. If there are bugs, all they have to do is go to a browser and then put in their the parameters, and boom, they're able to see that. So that is the crazy power that we've built behind the product. And we have a lot more work to do. We're just getting started. I'm not sure how deeply you want me to go into the engineering, but we've basically rebuilt every layer of the stack. I think that's one of the advantages of a bear market. In a bear market, you can just build. There's no distraction. There's no price action. It's actually the whole community is dead. So you can just focus on building. So for about 2.5 years, my co-founder and I were just sat down and wrote code every day. So for 6 days a week, for 2 years, all we did was write code, write code, write code, write code. So we rebuilt Get, so the Go Ethereum node. That stack has been rebuilt. There's some challenges with how to pull out data, which we've solved. We've rebuilt Postgres, because what we're doing is we're copying data from the Go Ethereum node to Postgres, but it has to be synced every 15 seconds because that's the block time. So we've rebuilt the storage layer there. We've rebuilt our schemas. We are on iteration 6 of our schemas so that they're super fast. We've rebuilt the query engine. So we have a re-implementation of MongoDB. We're calling this Primer. There's no MongoDB in our stack, but one of the beautiful things about Covalent's API is if you pull out something like the transaction endpoint, it's super rich data. It gives you all of the transactions. It also gets you all the log events. Everything is decoded. It gives you historical pricing. It may be sometimes too much data. So what developers need is some way to filter and project and sort and aggregate this data on the API side. So we've rebuilt the MongoDB query engine. It's completely in-house. We don't use MongoDB anywhere in our stack. So you can use now MongoDB query languages, query documents to filter, project, and sort and aggregate the responses from the API. So yeah, so we just have a fully vertically integrated stack that is now starting to pick up heat. All the big guys in the space, so 0x, Zapper, Zerion, Frontier, all of these guys, they Chain Guardians, NFTX, across DeFi, across social tokens, across NFTs, Covalent is the best API that's available today. So that's just the high level, summary of what we've been up to. I'm happy to take questions. I want to figure out what's the right path to go down. We can go more technical. We can go more business. We can go more about the state of the industry. Where do you think I should jump to? So happy to take some questions now to calibrate.
Let's go more technical.
Yeah, just a few questions. I mean, you talked about rebuilding your stack. So why choose Get and why choose PostgreSQL? I mean, with Get, you have so many other node implementations, maybe the Prisms implementation or some other kind of flavor instead of Get. So, I mean, why the choice of that specific stack?
It's a great question. So, yes, there are lots of clients for Ethereum, but Get has the most traction. It has the most activity. It's very expensive to maintain a public good like Get. And Parity, which used to be maintained for a very long time, recently exited to a DAO. And there was a bug, a showstopper bug, and they didn't have the resources to fix the showstopper bug. So they actually reverted back to a Parity from 2 years ago. So yeah, it's just the state of the art. Get is the most advanced client. So it made sense just from a technical architecture. If you look at all the other blockchains, they're all Get implementations. So you look at Avalanche, it's Get. If you look at Polygon, it's Get. It's all Get. Everyone has modified Get. So Get is the most flexible for node to work on. If you want to make it a core part, if you just use a node and use an RPC layer, any node will do because it's all compliant to spec. But if you've rebuilt the RPC layer, one of the challenges with the RPC layer on Get is that it's single threaded. So you cannot make concurrent requests to the Get node to retrieve data. So what we've done is we've completely sidestepped the RPC layer and directly export the blockchain data to a format that we can upload into Postgres.
Makes sense. So another question on the similar lines. I mean, you say you have so many partners that are coming in. So how are you exactly I mean, this is just a question that I was also talking with the Infura team. How do you actually handle the load balancing?
Another great question, but let me go back to the Postgres question. Why specifically Postgres? The Postgres interface has become the standard in the industry. So over the last 10 years, there are probably hundreds of databases. Actually, no, I lied. You go to the site, there's a db.io. It's a database of databases. There's over 600 databases that are available today, all the way from key value stores to graph databases to SIAM series databases to blob storage to regular, Swiss Army knife style databases like Postgres. But what is clear over the last 10 years is that the front end of Postgres, which is the networking layer and the query planner, has become the standard in the industry. So if you look at CitusDB, they've rebuilt the storage layer to be a sharded blockchain. The front end is Postgres. If you look at Greenplum, if you look at Astrodata, if you look at Redshift, even Redshift is a Postgres front end. You look at Timescale DB, it's a time series database. The front end is a Postgres. So Postgres has become the standard. And what's beautiful about Postgres is that the internals is a stack. It's an SDK to build databases. So Postgres itself is a database, yes, but it's very, very neatly lined out to the networking layer, the query parser, which is state of the art because SQL standards are not standards, the query planner, to the storage engine. And they have foreign data wrappers that let you push the query planner or the query execution engine into the shards or a foreign data wrapper. So it's very, very powerful in terms of a stack. So if you're trying to replace any layer of the stack, that is the best place to start. So why Postgres? Because Postgres is the most flexible when it comes to customizing the database internals. And you still have wide compatibility. Every language out there has Postgres drivers, be it languages, be it platforms. So it just makes a lot of sense to go with Postgres. So why Postgres? That's the answer. The third question, what was your third question about what these customers are using? Or how do you
balancing?
So yeah, so one of the tricky things about the blockchain space is the consensus. So there are some hosting providers that provide a very simple load balancing system. They just put Nginx in front of your get node, and then they load balance. That is a mistake. We will know if we use a host like that. So the way Covalent works is that you need a get node alongside our ingester that replays these blockchain instructions and then puts into a Postgres, and then we have the API layer. So it's like there's like 4 components in the stack. And if you're load balancing across your get nodes, our ingester will detect that and fail because of soft forks. So what happens is each node follows a different chain. So they're not actually synchronized, right? Until you have a reorg. So there are lots of soft reorgs. So in terms of load balancing, what we have is we've made our entire fleet of Postgres clusters atomic when it comes to reorgs. So the way we do that is we use a trick on Postgres called table partitioning. So you can attach and detach table partitions, and you can make that atomic. The DDL on Postgres is also ACID compliant. So that's one of the beautiful things about Postgres. So if you're modifying the table partitions by adding new blocks and new transactions and new log events, you can actually you can wrap that around a transaction and roll it across your fleet of Postgres. And for any reason, if a transaction fails, everything gets rolled back. So what the customer sees is a consistent view. So even if the load is balanced across multiple blockchains, the data is not different. You can't sync each Postgres database individually. Otherwise, if they make requests, if you don't pin it to a certain database, they'll get inconsistent results because the blockchain itself is inconsistent, at least the head of the blockchain. So that hopefully that answers your load balancing question.
Makes a lot of sense.
Ganesh, you mentioned you're working with a lot of other blockchains as well. Can you name a few?
Absolutely. So we started with Ethereum. Now we're fully supported on Polygon, which used to be called Matic, one of the top projects from India. We actually just wrapped up the Etherpunk hackathon with Polygon. We're also working with Binance Smart Chain. We're also working with Avalanche. And in the next 2 months, we will have Near support and we'll have Elrond support. But we're blockchain agnostic. You use the same API, just change the chain ID and everything just works.
Awesome.
Yeah, when it comes to basically supporting any EVM, it's relatively trivial on our end to do so, and it also provides a pretty seamless experience where all we need is the EVM chain ID.
Any plans to move out of the EVM? Look on chains that support anything other than EVM?
So Near and Elrond are non-EVM based chains.
Yeah. So how are you tackling, let's say, the reorg of blocks you mentioned when you were answering Anand's question? That may not happen on certain high throughput chains. Would that cause an issue on your data layer, maybe, or wouldn't it?
So one of the things that we do say is that we're always 2 blocks behind the blockchain, right? We never sync the mempool in-flight transactions. We never sync the head of the blockchain. We're always 2 blocks behind. So in the case of Ethereum, it's 30 seconds behind. In the case of Matic, the block time is 3 seconds. So it's always 6 seconds behind. So that way we work around a lot of the more nuanced and complicated problems. So I think that is to our benefit. The reorgs on the other chains, I'm not exactly sure. I can't answer that question at this time because I was not involved in the technical work there.
All right, awesome.
Also, one of the things that was interesting with me while working with Covalent was, I mean, I've talked about this with Harish also. It's just that the simplicity of integrating Covalent, which would also be sort of appreciated by all the other fellows in the program, was that you don't have to build your own custom adapters similar to something like the graph, wherein you maybe have to learn assembly script, figure out the entire syntax, build your own schemas, sync the entire graph nodes, and sort of maintain your entire code base, whilst all of that implementation is actually offloaded directly to Covalent. So what I want to ask over here is, just like you have adapters for Aave, you have adapters for other governance proceedings, and essentially be able to just access the data directly from the API layer. Are there any plans to sort of open source this layer and allow the community to actually build the adapters off of the data that is available directly on Covalent?
Excellent question. So we have a new homepage that's shipping in about 10 days that'll directly answer this question. So let me tell you a little bit about how we built Covalent and why we built the way we built things. So Covalent has Class A endpoints and Class B endpoints. Class A endpoints are things like get your token balances, get your log events, get your transactions. These are inherent to any underlying blockchain. They're supported across all of the blockchains that we support. That's like the MVP. So the Class A endpoints, it makes a lot of sense. You want token balances, just use this endpoint. You want all of your NFTs, use this endpoint. Super simple. You want to get the token IDs from an NFT, use this endpoint. It works the same across all blockchains. Class B endpoints are specific to the protocols that's deployed on a blockchain. So Aave and Uniswap on Ethereum mainnet, maybe PancakeSwap on Binance Smart Chain, probably EasyFi and Polymarkets on Matic, and Pangolin on Avalanche. When we started out in writing these Class B endpoints in 2019, there were only 10 dApps in the world, right? It was like Maker, Compound, there was like GYDX. It was very simple. So we just sat down and wrote those connectors. It was very, very simple. And we got product market fit and customers loved it. Now they're over 100. And I would say by end of this year, there'll be at least 1,000. No way for us to scale. So what we are actually doing is we're building the tooling for anyone to create their own Class B endpoints. All right, so it's all like open source, but essentially how the Class B endpoints are built is they're built using the Class A endpoints, because you have the raw transaction data or the raw blockchain data, and then you format it and you munge it and you shape it into something that makes sense for a protocol, right? So the Class B endpoints is going to be a marketplace. So one of the cool things we have is we have a token coming out. So there'll be a big announcement in the next 60 days about the token. And what is beautiful for developers is if they go and create a Class B endpoint and then put it up on the marketplace, they can earn revenue from the Class B endpoint, this API endpoint, depending on usage. So it's like a market.
Is it similar to the indexer approach that Graph Protocol has? I mean, everybody's running their own sort of Class B endpoints, and if somebody is hitting my Class B endpoint, they have to pay a certain amount.
Exactly. So it's similar in scope, right? But the implementation and the logic and the philosophy behind it is different. So I can even go into like the specifics of how we're different from the graph. I think that's also very interesting.
I mean, it's fine by me.
Okay.
Yeah, I mean, we were definitely using the graph as a bit of a model there, but imagine you've got a marketplace of APIs so that any Web2 developer can be using this. You don't have to figure out how to shoehorn in some sort of customized subgraph into your project.
Exactly. Yeah, and it's similar to Rapid API, which is essentially a marketplace
Exactly.
for APIs.
Yeah.
Exactly.
But the difference in philosophy here is that we've already copied out and indexed the entire blockchain. So our Covalent database, the Postgres database, has every block, every transaction, every log event, everything. So it's a multi-terabyte database with 100 billion rows. So we already have done that hard work. So now all you're doing is essentially pivoting that data from that base layer rather than re-indexing. So our focus is more on the query layer and the business applications rather than, oh, how do I go retrieve this data from the blockchain? How do I build the indexer? Because we've indexed everything for you, right? We've just done the hard work for the community. So you can build these subgraphs equivalent using drag and drop tools. That's what it comes down to, right?
That would be way easier for people to come, because I remember when I was doing like understanding the entire philosophy of subgraphs and the entire graph protocol and how to get into that ecosystem, it took me like a week to figure out how assembly script works, and it has those nitty-gritties of immutability which are just way too complex for any sort of beginner or people who are transitioning from Web 2 to Web 3 ecosystem to just get hit by, and they'll just languish the entire project and just be like, okay, I don't want to use this program. But Covalent actually just simplifies that to a very, very large extent.
There's also a deeper technical difference which matters. So if you look in the database world, nothing really has changed in the last 40 years, right? Larry Ellison read Codd's relational theory papers and founded Oracle. Since then, it's basically been the same. There's been no major paradigm shift. But over the last 10 years, the database stack has been basically reinvented. So if you look at how data moves between data systems, it's always been ETL tools. So extract, and then you transform, and then you load the cubes into a data warehouse, and then you query that data warehouse. This is why companies like Informatica, which I'm sure a lot of you guys have used, are very popular. They make billions of dollars in revenue. But over the last 10 years, what has happened is because of the usage of cloud native architectures and columnar storage and block query execution engines, you can now do the transformation at query time. So you just extract and load data, and then you transform it using joins or using other projection operators at query time. And this is why databases like Snowflake are so popular. So Snowflake, it was the second biggest IPO of last year. They're so popular because they've rebuilt that stack. So Covalent is more of that style rather than the old style of, the subgraph is basically the transformation. Like if you need to ask another question, if you need to aggregate on another dimension, you have to build a new subgraph. It just doesn't work, right?
Exactly. And
with Covalent,
because you've already indexed everything, with like subgraphs, you have to reindex everything. So
absolutely,
a prime example would be Uniswap. If they have to make even the slightest change in their subgraph, it takes another 30 days for the entire subgraph to reindex throughout the entire block.
So those are some of the challenges with the ETL approach. So you extract, transform, and load, as opposed to the extract, load, and then transform at query time. So if you look at our MongoDB clone, which we're calling Primer, you can aggregate on any dimension, you can filter, you can sort, you can pivot. Everything is out of the box, right? and you choose at query time what data you want, rather than when you're writing the transformation step. So that's really the shift in the thinking. So it's upside down, and we're very confident with our approach.
Doesn't it make it less scalable though? Wouldn't you effectively face a lot more latency if you would have transformed it beforehand, like with the case of subgraphs?
Not really. No, because of columnar compression and block query execution, I would say they're within the realms of what is fair. So, for example, our ERC20 balances returns in sub-second, 300 milliseconds, right? So it's not like, computers are very, very fast these days. So you can definitely reach hyperscale on the cloud to handle the load, and it's all read-only data, so it's faster to scale it up too.
Exactly,
And that
because
wouldn't
even get calls, because if you're looking at blockchain data, as you've already said, taking data out of the entire get node is just so slow. I mean, even if you have implementations like multi-call, it's just very slow. And to have that all indexed, and if you just have to ship even with a couple of transformations, it's way easier to do, and at least faster.
Anshuman, you had another follow-up question?
Yeah, I was asking, as we shift towards POS and other consensus algorithms, when the TPSs improve, would that still be an issue, what we were discussing about before?
Not really. So let me tell you a little bit about what our extraction process is. It's very interesting. I think we don't usually open up with it because it's very, very technical. One of the unique things about Covalent on the product side, is what you guys have all probably used, the REST API and all of those business benefits, time to market, and all that stuff. But there's some really core differences in how we've built our stack. So we have access to contract storage that nobody in the space has. So not only have we indexed every single transaction, log event, and like everything on the blockchain that's visible on the outside, basically the transaction receipts, we also have the storage. So what this means is that if you have a smart contract and it follows a certain interface like an ERC20.
So, I mean, just to confirm, just so that I'm following, it's essentially the get storage at kind of variable. And if you have if you know the contract size, and essentially the ABI is having the ABI of the contract necessary in getting the storage layout?
Absolutely. So that is 100% correct. So what we have is not only what is emitted from a contract during the state transitions, we have essentially the database behind every contract. So what Solidity does is it exports type maps of your data structures, basically the storage layout. And so we export that type layout, map it onto a custom get, replay every transaction, and figure out how the storage is modified, and then snapshot the storage for every S-store. And then that is available to query.
Would this impact, so I mean, I'm getting into very technical details. I don't know if the fellows would like, I mean, if you have any issues, just feel free to speak. But my question here is that once you're actually changing contract implementations, I mean, if you have a contract behind something like upgradable proxy or some sort of implementation wherein you have the actual contract code that is pointing to a specific address changing. So now if you have the contract code changing, would that affect the sort of mappings that you have? Because let's say if for one table you have 5 rows are getting 5 return parameters, and after a certain block you suddenly have 6.
Not really, because we're not actually changing the program itself. The program hash continues to be the same. It's just the execution results from the trace is mapped back into the storage layout. And if the storage layout changes, the ABI changes. So we will have to map the ABIs again. but we have access to 40, 50,000 APIs already. And most of the important contracts, they're all the same programs. Like every Uniswap exchange is the same program.
Yeah.
They're just initialized with a different set of parameters. So most programs on the blockchain are actually the same. So we are just able to decode all of that stuff. So now having access to that storage in a JSON format as a time series is super, super powerful. So you can get all of the token holders of a contract, of a token, as of a particular block height. This is a question that nobody in the space can answer, except Covalent, of course. No, I wouldn't say something that no one in the space answer. Covalent can obviously answer that. That's why I'm telling you about it. So that's an example where literally, like, you just need to pull out that map of, token holder and then the balance. And then you can figure out the historical balances. You can figure out whatever you want. Like that is the level of extent that we are going towards. Of course, the data is now blown up from 5 terabytes to like over 100 terabytes. So, but that's fine. 100 terabytes is still small data.
Maybe I'll jump in here because I know we've got about just under 15 minutes left, and we've gone really deep into the technical stuff. I just wanted to get a gauge because I just got the sense from Denver. The rest of you may not be sort of at that same level of detail as you've sort of gone through this brief journey from Web 2 to Web 3. We can do a quick API demo if that would be helpful. If you guys are interested in learning more about the use cases, we can talk about that. But maybe get a few of the other folks on the call here to suggest what they'd be interested to hear more about. Like what are some of the challenges you've run into just in your brief sort of experience here as you sort of dwell into the blockchain space and Web3?
Yeah, anyone want to mention? Like, so I think some of them have the only equivalent some of them have worked with is the graph, but not all of them. So
something I guess would be interesting for everyone would be to just show a quick demo of Covalent, maybe the classic Class B APIs, so that they just know where to use and what to use and what parameters just to get the data and start building.
Yeah, that would be great.
Yeah, happy to do that. I know some of you may already be experienced with using our APIs, but I could quickly show you what this looks like in practice with using the doc site. And I share that link here in the Zoom. So if you want to follow along here, you can sign up for a free API. Right now, we're just allowing anyone to access the API and use it basically at relatively full load. So Ganesh had talked about this concept of Class A and Class B, where Class A are generic endpoints that can be utilized across multiple networks. And basically, to query across networks really just requires a change in a single parameter, which is the chain ID. So right from the docs, for example, if you wanted to take a look at all the balances for, let's say, demo.eth, we've got the built-in ENS domain name resolver. So you can put in any ENS, I should say, not DNS. You can put any ENS value in there, and it will automatically resolve the underlying wallet address and give you the balances. And it's really just as simple as putting in, let's say, demo.eth. And we've sort of pushed on the underlying decoded logs and information around NFTs. That is obviously an area now that we're seeing huge interest in and sort of an explosion in the marketplace. So being able to distill the underlying NFT data is something that we have heavily focused on by providing some custom endpoints specifically around NFTs. So we can focus in on getting back those details. And what's I think relatively unique about the API that we provide is you don't get just a JSON option for your response. You can actually get this data back in CSV. So if you feel more comfortable taking this data and putting it into Excel or Google Sheets and then using pivot tables, we really try to empower all skill levels to be able to leverage and utilize this data. So I can, for example, just show you what this would look like. And you can effectively just copy this and paste this directly into a Google Sheet or Excel. So Class A, again, sort of talks upon having the ability to query balances, get log events, get decoded log events, use topic hash. I think one of the really powerful tools that we have sort of in tandem with the API docs is information that is available on our generic doc site. And I'll also share that link with you here, where we've got, in addition to just directing you to the API, we've got things like tutorials, we've got information around our campaigns. So these are sort of really good onboarding campaigns where those who are doing exactly what you're doing, which is sort of going from the Web 2 space to the Web 3 space, are able to understand how to use some of the blockchain data, understand transactions, understand decoded log events. We've got, as part of, for example, 1 million wallets, a whole host of developer resources from code templates, where you can literally go in and be able to execute these little code snippets that we've provided through Replit, which is a fantastic cloud-based IDE. And so you can sort of run these little code snippets and then go in and actually modify the code and play around with it and change it up to your personal preferences. And again, a great onboarding tool if this is, again, a space that you're just getting introduced to. We've also got our current Dungeons and Data. So this is more, again, focused around the data scientists. And that's where having the ability to pull out this data and put it into a Google Sheet or an Excel sheet and use the more traditional tools, or even put it into Tableau and be able to create some really cool visualizations. We've seen our community do some great things by leveraging data in CSV format. We talked a little bit about some of the supported networks. So each network has got its own dedicated landing page where we talk through some of the quick details and merits of that particular network, as well as the chain ID, block explorer, and some other interesting information around the endpoints that we support. And then we've got the Alchemist Cookbook. And what's cool here is this is just going to be built out as a series of how-to guides and case studies where anyone can sort of follow along. They're written at a relatively sort of easy to understand level, and we kind of guide you through using a particular API endpoint. We guide you through the use case of where this type of analysis might be useful and what the underlying purpose and sort of motivation for doing this would be. And we've also got some tools that we're building out. The topic calculator is a really cool one. So if you want to quickly look up the topic hash for any contract, you can literally just put copy and paste in that topic or put in the contract address, and it will spit out all the topic hashes. If you try to find this on Etherscan, it's almost a nightmare trying to scroll through and figure out what the particular topic hash that you need to do any type of analysis. So we've got all those tools built in here for you to make it as easy as possible for your transition from Web 2 to Web 3.
There's a lot going on. Yeah, there's a lot going on here. The topic calculator, for example, can decode proxy log events. So we query events that have a different sender and then decode those API documents and then bubble them up to the proxy contract. So there's a lot going on there. The Alchemist Cookbook, things like the tether analysis is actually packaged as class assignments in about a dozen universities across the world. So you just have to follow those step by step. Yeah, there's just a lot going on here.
Yeah, just two questions, like just two things from my end, and they're just going to be pretty new ones. Like, uh, so how does one use this in tandem with something like Dune Analytics or something like that?
So Dune is a layer below Covalent, right? So Dune provides the raw API data or the raw blockchain data in a way you can run SQL. What we've done is we've packaged the SQL into this API endpoint. So the audience is different. That is for a data analyst. Here it's for a programmer.
Got it. Got it. Also, like I heard Harish mention some visualizations, and I would, wouldn't mind seeing some of them, like always. Great to see some cool visualizations. Maybe.
Yeah, we've actually got, this is probably a great time to highlight our recent initiative, which is this Alpha Alarm. And so basically a daily tweet with a very interesting visualization goes out, built by our data research team. So this is kind of a really interesting initiative where every day we'll sort of post some sort of interesting bit, and it'll be sort of part of a series. So what we looked at this week was this concept of battle of the dexes, and looking at Uniswap, PancakeSwap, sort of comparing sort of volumes, transactions, and presenting some interesting visualizations around that. So if that's something that's of interest to you, I'd recommend on Twitter just following Alpha Alarm, and you'll get that every day with the interesting tidbit that you can slice and dice as well, and do some your own analysis with it.
Yeah, that looks great. That looks great.
Something from a developer point of view would be also interesting to see is because you're offering all this data across HTTP essentially. A GET request, what would be interesting would be to get this over WebSockets also. So, I mean, that would allow people to actually subscribe to those feeds. It's similar to the question that Anshuman just asked in the chat, is whether you can actually get the data in sort of streaming fashion. So, I mean, once you've got that WebSocket functionality, you can plug it into absolutely anything. And even the HTTP layer, you could plug it into something like IFTT, and then just once you've got that entire string going, you could maybe send out a tweet related to that data, or maybe send a Slack message and whatever it is that you want to build.
Cool. I know Ganesh has to jump off here, and that's a great point that you made there. I see that also in the chat. Maybe one last thing I'll leave you guys with here is we are actively recruiting as part of our ambassador program, and this again is really meant to engage the developer community to be building and using the Covalent API. So if that's something that's of interest to you, to be a more integrated and core part of our ecosystem, we're ramping this up as we get to our token launch within a 60-day time frame here. And so I'll share this link if anyone's interested in wanting to learn a little bit more and joining our sort of extended family, if you will, as part of our Alchemist ambassador program. Cool. Denver, really appreciate the opportunity for us to speak with you guys. And I know Ganesh can talk about this technical stuff all day, can go really, really deep, but for everyone else who may not be at that same level, hopefully some of the resources that I shared here are at a suitable level to go in and be able to understand at a bit more of a higher level and sort of build your skill set and go deep with Web3.
Sure. So I can see Ankit had one question. Maybe Ankit, you want to go ahead?
Yeah, sure. So basically, I was like trying to look at like how to track minting on Polygon, like minting and burning, right? So basically, the way that I was trying to use Covalent was to use get transactions and then see transactions from 0x0 to track the minting and burning, right? But the point is you get the information only as a part of log events. And
Right.
and so basically I kind of, if I have to fetch everything other than log events, as it takes a lot of time, but I can skip out the log events, but I don't have the option of doing it the other way around, where I don't want the other options, but I only want the log events. So
Right.
is there a way of implementing it, or like, if not, then like just a suggestion that
Yep.
that's it.
So this is actually where Primer is going to play a role, where you can sort of target in on the data that you want. It's almost like, to some extent, it's like building like a mini version of a subgraph where you can target in specifically on the data that you want. So that will be a feature that's going to be rolled out pretty soon. It'll do exactly what you were just mentioning there. You're not the only one that's raised that issue before.
Oh, all right, that's great to hear. Thanks.
No problem. Okay. Again, thank you so much, Denver. Really appreciate that. And
Thanks for making the
again,
time.
we're open. Feel free to share our contacts if anyone wants to get in touch with us with any follow-up questions.
Sure. Yeah. So I think yeah. What would be the best place to contact you? Do you have a Discord or something, or?
Yep, we've got a Discord. I'll actually just share that right now. We're on Discord and Telegram, Twitter, the usual places where we're hiding. Well, not hiding, but we're available. Let me just get that for you. And I'll paste it.
Cool.
Awesome. Thank you so much, everyone. Really appreciate your time and listening to us today. And again, if you've got any questions, feel free to message us in our Discord. We're happy to help.
Great. Thanks for making the time.
Okay. Take care.
Bye-bye.